Alrighty, now let's look at a simple step response example where, in this case, we're going to have a 24 volt source, a switch that at t equals 0 closes, and this time we are going to charge the capacitor. Let's say that this is a 5 kilo ohm resistor and this is a 0.1 microfarad capacitor. And initially V sub C at 0 minus is 0. In other words, there's no charge on the capacitor, which means immediately after the switch closes, there's going to be no charge on the capacitor. And it's going to charge and continue to charge until the voltage on the capacitor equals the source voltage, so that there is no voltage difference across that resistor. As long as the voltage on the capacitor is less than 24 volts, you'll have current flowing, causing the capacitor to continue to charge. So in this case here, the final voltage is going to be 24 volts. Tau is going to be R times C, which is 5 times 10 to the third times 0.1 times 10 to the minus sixth, which is 0.5 times 10 to the minus third, or a half a millisecond, which equals 0.5 milliseconds. Now, again, we know that the voltage across the capacitor as a function of time is equal to V final plus the initial minus V final e to the minus t over tau. So we have our initial voltage, we have our final voltage. This then is going to be 24 plus 0 minus 24 e to the minus t divided by 0.5 times 10 to the minus third. And that equals 24 minus 24 e to the minus t divided by 0.5 times 10 to the minus third volts. And we can even factor out that 24 if we wanted, which would be 24 times 1 minus e to the minus t divided by 0.5 times 10 to the minus third. So we see what's happening here on this. This capacitor is charging up to 24 volts. It starts at 0 volts. So at t equals 0, we have e to the 0. Well, e to the 0 is 1. 1 minus 1 is 0. So 24 times 0 is 0. Sure enough, it satisfies our initial condition. Now, as t goes to infinity, we have e to the minus infinity. Well, that's 0. 1 minus 0 is 1. So the final voltage on here is 24 volts. And we can graph that. It starts here at 0. It's heading to 24 volts. This is V sub C as a function of time. Starting at 0, it's going to 24 volts asymptotically. Once again, we know that within about 4 tau, so that's about 4 tau. Tau is 0.5 milliseconds, so 4 times 0.5 milliseconds is 2 milliseconds. Within about 2 milliseconds, it will be to real close, 98, 99% of its final value. There's 2, 1, so this would be 0.5 milliseconds, 1 millisecond, 1.5 milliseconds, and there you've got it. The current here, once again, if we define the current, we define the voltage like this. Explicitly it was there. We didn't ever do it, but it is like that. Now, if we define the current like this, and let's change colors to do so, I sub c as a function of t is equal to c dv dt which is equal to 0.1 times 10 to the minus 6th. That's C. Now, what is the derivative of that right there? Well, the derivative of a constant is 0. So I'm going to just write it like this. This will be dv dt. I've got a negative 24 times e to the negative t over that. Well, once again, that kicks out a negative 1 over 0.5 times 10 to the minus 3rd. E to the minus t over 0.5 times 10 to the minus 3rd. Probably didn't need those square brackets, but they're there. And that then equals, I've got a minus times a minus. The current is going to be positive. Get the calculator out for this. 0.1 minus 6 times 24 divided by 0.5 EE minus 3. That turns out to be 0.0, so 4.8 times 10 to the minus 3rd, or 4.8, we'll do it in terms of milliseconds, or milliamps rather, e to the minus t over 0.5 times 10 to the minus 3rd milliamps. Notice that it's positive. The current is positive, meaning that it is flowing, according to our reference, it is in fact flowing in this direction, as we expect, because when we close the switch, current is going like that. At t equals 0, e to the 0 is 1, so it starts at 4.8 milliamps. Let's do this on a separate scale. 4.8 milliamps, and it dies out asymptotically. There's 4 tau. Something like that for I sub c as a function of time. Both positive, but the current starts out at a maximum value and dies out to 0. Does that make sense? Sure. When there is initially no voltage on this capacitor, you're going to have your maximum current. And it turns out that that maximum current, we could calculate that. When V equals 0, at t equals 0, the voltage on the capacitor is 0. So the current is going to be the current through that resistor, which at that instant would be the 24 volts minus 0 volts. So we've got all 24 volts across that 5 kilo ohm resistor. We go 24 divided by 5 EE3, and sure enough, that initial current there, I sub c at 0 plus, we can also calculate to be 24 minus 0 divided by the 5K equals the 4.8 milliamps. Again, doing that independently just from knowing what's taking place in the circuit, we can verify that that initial current is the 4.8 milliamps, which is what we calculated over here by going C dV dt.